So welcome everybody to this latest video on 162 Maths, and in this video we'll be continuing with the theme by going through some GCSE Maths higher big mark questions taken from some past papers. Now as always there'll be a copy of the questions that we go through, which I strongly recommend you have an attempt at before watching through this video as we go through the answers. So let's first have a look at the question breakdown of the 6 questions that we're going to go through. So as you can see that a lot of the questions are exclusive to one particular topic, with the exception of question 2 and 6 maybe, but the topics of cumulative frequency box plots go quite hand in hand, likewise with area of a sector and the area of a triangle. Now, there is no classification as whether the questions are non-calculator or calculator, so I've kind of just made an educated guess as to which is which, but if you're ever unsure, always try and attempt to work out a question without using a calculator unless you desperately need to, or it would dramatically speed things up if you were to use a calculator, but always show your full working out. So let's get started on question 1. So question 1 says use approximations to estimate your answer to this. Now looking at this, what we want to do is we want to make sure that we want to round numbers to the first significant figure, and also with roots we want to round to the nearest square number. So if we look at this particular value here, so we've got root 97, so that is approximately root 100, which equals 10. Then if we take this here, so we've got 2.014 cubed, so 2.014 cubed is approximately 2 cubed, which is equal to 8. And then with the bottom one, so here we've got 0.49, and that's approximately 0.5. So if I substitute these 3 values into this to approximate the answer, then what we get is we get 10 plus 8 over 0.5, which is 18 over 0.5. So how many halves go into 18? The answer therefore is going to be 36. Moving on to question 2, which looks at cumulative frequency. It says the cumulative frequency graph represents the masses of 40 necklaces. A jeweler buys every necklace with a mass greater than 21 grams. Use the graph to estimate how many she buys. So what we need to do is we need to find 21 on our x-axis, or the horizontal axis, which is just there. Now one thing that a lot of students tend not to do is they tend to forget to draw the lines. It's really important, as this is a form of showing your working out. And again, you want to try and use a ruler to try and be as accurate as possible. So the working out's on the diagram, and I can see that less than 21 equals 15. So there's 40 necklaces altogether. So more than 40, more than 21 grams I should say, is going to be 40 take away 15, which gives me an answer of 25. It then says for B, the lowest mass was 3 grams, the highest mass was 28, and we want to draw a box plot to represent the data. Now with this, what I need to do is I need 5 bits of information. I need to know the minimum point, I need to know the lower quartile, I need to know the median, I need to know the upper quartile, and I need to know the max. Now in the question it tells me that the minimum value is 3 and the maximum value is 28. So I've now got to use my cumulative frequency diagram to tell me what the quartiles are going to be. So halving 40 is going to be 20, so that's where the median is going to be. So I work out the median to be roughly around 22. Then with the lower quartile, so the lower quartile is between the lowest value, or the 0 and the median value, which is at 10. So I go up to 10 and I make that out to be around about 18. Now I do the same with the upper quartile, so the value that's in between 20 and 40, which is 30, go across and I make that out to be about 24. So then these are the values I then need to plot to draw my box plot. So 3, 18, so I've got 3, which is here. I've got 28, which is there. And then trying to remember the middle 3, so 18, 22. So 18 is there, 22 is there, and I think the other one was 24. Yes, it was. So that's going to be there. Now again, I'm not really showing good practice because I should be using a ruler, but generally speaking, your box plot should look exactly like that, but obviously a lot neater with the lines a lot straighter. Moving on to question 3, it says the first two terms of a quadratic sequence are 10 and 17. Here is some information about the sequence, and the question is asking us to work out the nth term of the sequence. Now this question has been quite nice in the fact that it's given me the second difference, so what's going to be in the formula is going to be half the second difference, so it's going to be 3n squared plus the difference. So the next thing for me to then do is to work out what 3n squared is going to be. So if I just write n, or actually I can write n there, and then what I then want to do is write 3n squared. So 1 squared is 1 times 3 is 3, 2 squared is 4 times 3 is 12, 3 squared is 9 times 3 is 27, and 4 squared is 16 times 3 is 48. So then from this, what we can then do is write down these values. So I've got 3, I've got 12, I've got 27 and 48. Now the numbers in the sequence are 10 and 17. I could work out what the others are going to be. So here I've just got to do 13 plus 17, which is going to give me 30. The next difference is going to be 19, so that's going to be 49. So then from this, what we can then do is to then work out what the difference is going to be. So how do I get from this number to that number? So looking at the difference, it's going to be, I need to plus 7, then I need to plus 5, then I need to plus 3. So if I just write 27 and 48, and then I need to plus 1. Now this in itself becomes a linear sequence. So then looking at the difference, I then need to find the nth term of this. So I've got 7, 5, 3 and 1. N is 1, 2, 3 and 4. So now looking at the difference between each of these, it's going to be minus 2. So then the nth term for the difference is going to be minus 2n. And then how do I get from minus 2n, minus 2 to 7? Well, I need to add 9. So then from this then, here is my difference. I then need to swap that with this. So then the nth term for this quadratic sequence is going to be 3n squared minus 2n plus 9. Moving on to question 4, it says work out the value of 5 over 7 to the power of minus 2. Give your answers a mixed number. So a couple of ways in which we could do this. We can either, now if it's come up poorly on your screen, let me just write it out again. So we've got minus 2. So here I could either sort out the 2 or I can sort out the minus. Now sorting out the minus, that means the reciprocal. Now the reciprocal of a fraction, we just flip it. So that then becomes 7 over 5. And I've then got to square that. So 7 squared is 49, 5 squared is 25. I then want to convert this as a mixed number. So how many 25s go into 49? That's going to be 1, and the remainder is going to be 24 25. So the answer then is 1 and 24 25ths. Moving on to question 5, it says show that we've got this surd. So what we want to do here is to try and simplify where possible. So in terms of 150, so root 150. So thinking of a square number that goes into this, well, it's going to be 25. I think it's going to be, I'm not sure if that's the biggest. So we've got 25 multiplied by root, and it's going to be 6. And so simplifying that gives me 5 root 6. So then this, if I just highlight that, and this, I can't simplify root 6 because there's no square number that goes into it. And root 2 times root 3 is root 6. So then swapping each of these in, then what we get is, let me just write it out again, so root 50 minus root 6 over root 2 times root 3 is the same as being root 6, 5 root 6 rather, minus root 6 over root 6. So looking at the top, well, that's going to give me 4 root 6 over root 6, and we can then cancel the root 6, leaving with a final answer of 4. Then moving on to our last question, it says that the vertices of a regular hexagon lie on a circle with centre O and a radius of 5. Work out the shaded area, give your answer in the form of this expression, which I'm not going to read out. So looking at the shaded area, so it's always good practice to actually find out what calculation you're going to be using. So it's always the big shape take away the small shape. So it's the area of the sector minus the area of the triangle. So I need to find out these two things first. So if I just label these as #1 and #2. So looking at #1, the area of a sector, the formula is theta over 360 multiplied by pi r squared. So if I substitute those numbers in, well, I've got 60 over 360 multiplied by pi multiplied by 5 squared, which gives me 1/6 times pi times 25, which equals 25 over 6 pi. And I'm going to leave my answer in that form for the time being. Then to work out the area of the triangle, so for this I need to use the sine rule, so I'm going to be using a half AB sine C. So that's going to be a half times 5 times 5 times sine 60. Now you should recognize that sine 60 is a exact value trig, which we need to remember, and if you remember it correctly, it is the value of √3 over 2. So this is √3 over 2. This is 25, and that is a half. So if I multiply all of those three things together, I get 25 √3 over 4. So the next thing for me to then do is to then add these two, take these two things away. So here I've got, if I just move down a little bit, so here the shaded area is going to be 25 over 6 pi minus 25 √3 over 4. Now, as you can see, I haven't got a common denominator, so here I need to rewrite these fractions so that they have got a common denominator, and I'm going to use 12. So this first fraction I need to multiply by 2, so that's going to be 50 pi over 12. And this second fraction I need to multiply by 3, so that's going to be 75 √3 over 12. Now you might be asking, do I need to multiply the √3? Well, technically no, because it's only the constant that we need to treble in this case. So from this I can then write this as a single fraction. So I've got 50 pi minus 75 √3 over 12, and that does look like this format, and so that there is my final answer. And so here, I don't know why they've put this, but I'm just going to write down the answer here. So I've got 50 pi minus 75 √3 over 12, and there is my final answer.